So, vielen Dank für die Einladung. Ich bin sehr froh, hier zu sein. Und jetzt, I'm stopping speaking German. I now speak English, so forgive me. But in social conversation, I can speak, but not when I'm delivering a very pressured presentation. So I'm from Newcastle University, which is in the north of England. I'm part of a large team in the Hub for Biotechnology in the built environment. There's over 70 of us now, so it's a very big group. And I also co-head a new school called School X, which is all about collaboration and cross-disciplinary right across the university. So it's a rather radical shift for the university, and I'm delighted to take it on in the latter part of my career. I'm going to talk a little bit about, let me see where I am, a little bit, in fact, I'm not going to talk at all about the background. So I began working on material development because that's where I sit. So I'm an architect, but I sit very firmly in those very early stages of material development. I spent years trying to persuade students to do this, and nobody would do it, and so I then ended up taking that on. So it started in 2004, 2005, and I began by working with a textile designer. We work with concrete and textiles. We ended up patenting the technology, commercializing, doing a spin-out company that sold across the world product. So I'm someone who can understand very conceptual ideas and take it all the way through to fruition. But the two projects I'm going to show you today are not quite at that stage yet. But I'm not going to speak about this other than to say, the reason the title of your conference appeals to me is because all those years ago we did an exhibition called Fabrication and Misconduct, and I was the misconduct. It is very much built on a kind of feminist approach to material development, feminist approach to architecture in general, so you'll hear those echoes in how I speak. And really what I'm talking about is a radical values-led approach to material development, and it's cutting across the norms and trying to build new constituencies, new collaborations, and new methods. That's where I'm at. So the first project, which I'm going to go quickly to, is called Transplastics. I won't give you the stats, you can read them, but we have a mess of a planet. We are not recycling enough plastic at all in any of the countries around the world. And a lot of them are considered to be unrecyclable, or at least there are not yet markets for it, because it's the market that drives recycling, of course. And our project was really to design, so this is this is a fast project, so this isn't coming to conclusions, but it's beginning a new conversation about how we might deal with these waste sources. And it really was to design and prototype a building block, recycled plastic waste, all around kind of circular thinking, no fixings, and trying not then to cover it up with any kind of cement render. I'll show you some examples in a minute. But fundamentally, the one bit that's new to this, I suppose, is one, this is a design-led project, so I led the funding bid and the funding around it. A large complex team that came into it. It was supposed to be a year, it lasted a bit longer because COVID came along the way. But it's also about bringing design thinking and, crucially, user experience and critical user experience into that early stage of material development. So you can see there are already examples of people who have done recycled plastic blocks. They tend to be aimed at low-cost construction, crudely manufactured. They are also sometimes covered in mortar to hide them up. And interestingly, they're also pitched at the global south. So if it's not enough that they bear the excesses of us, they also have to be experimented on with these kind of rough technologies. In contrast, there's the work of Shara Mendelsohn, who's an artist in New York, and she takes plastic bottles that she finds on the street and turns into the most beautiful objects. I first saw her work in Leipzig in the museum, and I just thought, this is where I want to be in terms of thinking about recycled waste plastic. So at the same time as doing this, I was also quite interested in thinking around upcycling, the theory. There's quite a lot written about that. And upcycling culture is really where the consumer will buy into a value system. that exists in parallel to the upcycled product. So it's like architecture. There isn't just the material, there's also the conceptual, the ethical, the political that sits beside the material. And we have to always work those two at the same time. So people are buying into a range of values, you know, whether that be perceived reduction in environmental impact or reduction in landfill. It may also be because they want to be associated with an enriched product life story, one that's ethical and perhaps also has some sort of a sentimental element to it. So it's really value-led, and a lot of the writing around upcycling talks about the presence of the past in the future. So having a trace of what that thing once was, that's something that really interested me because I like that kind of narrative that can be, ethical narrative that can be taken through. So this is some of the early tests that some of our students were involved in as well. So on the far extreme, you'll see there's 3 interlocking blocks there. So that project we set every year for students, try and come up with an interlocking block that doesn't need any cement or render or anything. In this instance, they're making it from ceramics, but that project sparked the bid that we ended up then following through in the research funding. Meanwhile, we've got a polymer scientist who's focused on designing recycled blends of waste plastic and establishing their mechanical properties as well, and suitability for rotational molding, which was our choice of manufacturing. So we're looking for a very cheap, effective, mass way of manufacturing things. I'm really fundamentally interested in manufacturing because I once had to take ideas and manufacture, we set our own company to manufacture things, and I know just how significant it is in terms of cost if you overcomplicate things. So I'm always looking for the simplest ways of making things. So for instance, so in this, we're started to bring in more blending of polymers with other waste streams. So you can see some examples of hemp and sugarcane, and we also were crushing some recycled concrete and adding that into the mix, just trying a whole range of things. We brought some of these early material samples and also maquettes into workshops with people with sensory difficulties, with visual impairment. The onset of COVID stopped that, so we didn't really have as many workshops as we wanted, but even within that time, so it's very unusual to bring any users into this early into the stage of design, even in architecture. Very unusual. And so we did, and actually it brought a real shift in how we thought, because within, when we offered the samples up, particularly the ones that have got organic material in them, so we look at them and think, oh, those look nice, but actually they've got little micro undulations on the surface. And for people with a visual impairment, these are something that really appeals to them, because when they have a smooth surface, they feel claustrophobic. There's a claustrophobic feeling that comes from surfaces that give no sensory response to them. This is something I'm really interested in. I loved the idea of the fat brick, because I'm into fat things, not thin things, and I'm into rough things, not smooth things, and I'm into cheap things, not expensive things, and I'm into mass, not individual one-off things. So I'm very much at a different scale, I think, in that operation. So we wouldn't have known that. In the area of plastic manufacturing, those little things, those little undulations would be seen as flaws, and it would be thrown up, very much in the way that an architect will condemn a piece of smooth concrete because it's got some air blowholes on it. Nonsense, nonsense. Architecture, concrete's supposed to have blowholes. It's a liquid. So this was a real influence on us and allowed us to really get to grips with some of these materials. I won't talk too much, but we ended up, Robert, who did design tutoring with me, Robert Jameson, is an architect in Belfast, and he came up with the final form, and then we produced it into this. So I'll just show you this tiny, can I get this to work? Where is the moment? Yeah, so it's a little video, yeah. So I think without the interaction of people with visual impairment, the project would not be the success I think it is, because I'm very interested in these surfaces and these effects. The collaboration has meant that the project stepped beyond simply responding to the demands of the manufacturing process and also to from the technical performance of the material into the realm of responding to human and humane criteria. So that's quite something. So that's not just trying to satisfy technical performance, but also humane performance of materials. And to me, that would only occur if we had designers involved in the process. So that's, you know, critical. So the second project I'm going to describe very briefly, let me see, I'm just about in time, is part of the ongoing work as part of the Hub for Biotechnology in the Built Environment. As I said, I co-lead one of the research themes, this one, responsible interactions. I lead that with Ben Richens, who's a civil engineer. We have a range of research assistants who work with us, all of them from design backgrounds. They've all got some experience as an architect, whether that's just an undergraduate or postgraduate. And they work with us to essentially take the technologies emerging from the other three units, and we scale those up at the scale of a building scale prototype. We've got about 6 of those in the go, and I'm going to show you one in a minute. So the building you see is a building that was built during lockdown via Zoom. It can be done. I didn't know that. Ben and I led on that too. So that building is what we call the experiment building. It's not experimental in its construction, but it will become so because the elements we are able to take things out and replace them with the new technologies, and we'll be able to test it live. So the building has both a Cat 1 lab in the ground floor, and above that it's got what I would describe as an IKEA flat, which is there for us to test the microbiome of that space when it's occupied. So we've been swabbing the site before the building was built to see which microorganisms were living there even before we were on the site, and we're going to trace that history all the way through. And we also have, not great, but some assembly space. We've also got workshops in other places, but we have a little bit of assembly space, but it's chiefly a space of interaction because one of our responsibilities is to interact with industry and also the general public, because these technologies can induce fear and concern. So we have to drive this thing, the material, together with the cultural. Those two things have to go in parallel. So these are, so I'm going to talk about bacteriocellulose facade. So I'm sure loads of you know about this because this is out there. All of the students that I work with know more about this than I do. They're super informed. It's DIY culture, online forums, all of this stuff. There are people just making this stuff in their bedrooms. It's amazing, you know, it's a fantastic material. This is definitely one of the riskiest prototypes that we've done, very speculative. Because although bacterial cellulose, and you can see this is some of the form, it's been used in these different forms in fashion, Suzanne Lee at Central St. Martin's, and Heather is one of our students as well. Although people are using it for interior applications, no one has to yet put it outside. So unless, of course, and where's the camera? Anyone who's watching this wants to, you know, email me and tell me otherwise, because we're really interested to know. So you're my collaborators today, so please tell me if I'm wrong in this. But we believe no one else has decided or thought to put this material outside on a facade. So that's where we're at. Bacterial cellulose is essentially secreted, and this is I love this. So we're dealing with the waste of humans, at the same time we're dealing with the waste of bacteria. So the bacteria, in its normal day-to-dayness of being a bacteria, is secreting both acetic acid, because we're using the bacteria that forms kombucha tea. So you know that the acid, the vinegar taste of it, that's essentially the secretions of bacteria. Nice thought, isn't it? And then alongside of that, it also secretes, and you can see an image over here in the center, it secretes little strands of cellulosic fiber, and they float to the top. And so the scientists think that what's happening is that that's becoming a kind of guard against UV. It sits on interface between the medium that's created, so that's a tea and sugary thing, glucose mix, and the bacteria, and it secretes this and it floats to the top, and we can use that. It's called a SCOBY, so it's a symbiotic colony of bacteria and yeast. And the great thing is that life at all scales replicates. So SCOBYs are diverse communities, and we know that diversity builds resilience, don't we? We know that. I know it because I come from Northern Ireland, and we have tried to separate people out, right? So diverse communities, ecologies, are resilient, and therefore this type of way of manufacturing cellulosic fibre is very robust and very suitable for large-scale manufacturing. There are other ways to produce it. They're done in the lab, but they're kind of pure and a bit temperamental, a bit, you know, kind of very, too highly strung, I suppose, in a way. So we're interested in this way of growing it. And then the other great thing is that I mentioned that kind of acetic acid that occurs. What that does is that it creates a pH level that means that anything else dropping onto the surface of this can't contaminate it. So it's kind of a self-regulating, self-preserving manufacturing process, natural biological manufacturing process. Very interesting. So we grow it very simply in Euro boxes, which would be used mostly in the food industry. That we take a lot of our cues from how other people are manufacturing things. And we've done lots of experiments around the conditions for growth. A lot of this is produced in the publications. There's vast quantities of people researching this for scientific, medical applications and stuff. And for other applications, for food, for that matter. They're used in food and bubble tea, and there's a type of pudding that comes from the Philippines, nata de coco, which is bacterial cellulose. And so there's lots of research out there, as I say, mostly led by scientists. And of course, they have a very different way of framing and understanding this material than I or we do. But it is useful to help us. And so we are adjusting that kind of mix, that kind of recipe, but at the same time we're also adjusting it because we're bringing it into a feedback loop with the assembly process and the prototype in situ. And this is what it looks like. So when you hang it up, it looks a bit like pig fat. It's not, a lot of people find it quite icky. And I'm interested in that aesthetic response because, you know, aesthetic is part of the value chain, our value chain. So we have the aesthetic to the ethical to the political. And so I'm interested in what makes us like or not like things and how we react to it. It's very provocative for architects. I love it. For that reason. And so as it hangs, and so we're, you know, again, going back to that, I don't want any fixings, so we're simply hanging it onto a washing line, and it dries in place. It's a very forgiving method of construction. So if you can imagine, on day one, we hung this out for the first time on the 15th of December, and I'm supposed to be the growing up in my group. So I have, you know, we have RAs, younger people working with me, and I'm supposed to be the one who they trust. It's very difficult because I have no clue if this is going to work. And so we just decided that if it lasted for a day, we had success, right? If it lasted for a week, that was super successful. So you just kind of lower the bar as much as possible so that, you know, people don't get too nervous about, why have you wasted my life, Ruth? Right? So, yeah, so we do that. So we did think it would tear. We thought it would fall to the ground. I also thought it would be eaten by seagulls or birds, you know, because I'm aware that birds will peck out the putty around windows when it's got, wie heißt es auf Deutsch? Weiß es nicht. So, anyway, I've known it in German context, that's why. So this is what it looks like. So it's flat at the moment, so it's not overly inspiring to architects. We want to make it curvy because it's essentially this is a non-woven. I don't know if you know much about textiles, but textiles are mostly woven and they'll only move in certain directions. Non-wovens are like paper and they'll move in any direction. They've got fantastic three-dimensional capacity. This is that thing. So I love to collaborate with people who want to make this into a curved element, so come speak to me about this. So this is what it looks like, and this is a little glimpse into where we're going. This is beautiful, and this is like your work, right? Because I saw that little Hütte in Weimar years ago, that little bark-covered Hütte, yeah. I loved it, right? And I've been wanting to do bark-covered something, and I can't, because you did it. But this is great because this is a true composite. So what we're doing is we find a way. This is a master's student, Jay Holsworth, fantastic individual, who has had forbearance of working with me too. And I asked him to make biocellulose like concrete. And he did, so he's trying to integrate aggregate as it grows. Oh, I've overrun. Yeah, so I'll get to the point in a minute. So this is really interesting work. It's a real biomesh. We call it bio-sandstone at the moment. We think this has got lots of legs. Again, I'd love to speak to people about how we might use this. And biocomposites are definitely very rich research territory. So we're at the beginning of this understanding of this material. Now, if you bear in mind, we have been working with timber for over 10,000 years. Some of the earliest examples of timber construction are found in Germany, and they are 3 wooden wells that were dug into the ground and then clad with timber. And some of those timber constructions are so well crafted with stone implements, right? So no metal, really incredible. And so that accumulated knowledge and cultural understanding that we have had of timber, how are we going to do that with biocellulose? How are we can't waste 10,000 years. So that's why we need this collective mind, and we need a hive mind, and we need a hive set of hands as well, because we'll only really know it if we work with it. And we do a lot of bringing people in to do workshops, and we're trying to kind of build momentum around that, but we're still in the early stages. So I say the chief conclusion is this is a very viable building material. Yeah, very viable. So it's where we go with it, I have my doubts every so often. Is it really the case? But it is incredibly strong, very pure cellulose. This pure cellulose comes as pure cellulose, so it's got good tensile properties, and it's incredibly durable. And you can see there's an example down in the middle. So we're just about to produce a book of all of it'll be hopefully by the end of next month, and it will come out early next year. So you'll see all of the other prototypes that we're working on, some of which are really fascinating. There's a bio-knit one with mycelium, which is really interesting. I would say the other conclusions are to do with, I think architectural practice now has to start at the nano and the micro. Not everybody, but some people, come and join the happy land that I'm in. And I think we need to respond and be creative in our improvisations with the liveliness of living materials. It's a very different way we can't make the image and then force the material to make that image for us. We have to work with certainly at this stage, as we're getting to know one another, we have to work together with this material to work out what it wants to be. So that's a really essential thing. The other thing is, I definitely think we have to abandon these resource-intensive aesthetics that we have. Smooth, white, skinny, it's almost as if it's our bodies. We don't want to be smooth, white, and skinny, and nor should we ask it of our buildings, That Instagram life is not useful, it's not good for the environment, and we need to move away from that type of aesthetic. And I think we also need to try and find a way to inform others about this, because once we start telling people about the ethical dimensions of these materials, they will come on board. Okay? These are also there's quite a strong smell to this. I encourage you to smell it. It's at the back of the space. So it's not just the visual, it's also the whole physiological experience of it. And let me see what else I wanted to say. Yeah, and it's, we have to embrace that the end user isn't just at the end, they're also at the beginning. They are there on the site before we even build, and those microbes become part of our toolkit, and that's something we need to consider. And it's really about understanding that it's more than just us. And I would definitely say, and just say it again, we have to demand much, much more than the technical when it comes to the built environment in the future. So thank you so much. Fantastic opportunity. Thank you.